In 1927, the world's leading scientists gathered in Brussels to make sense of 3 decades of new discoveries in physics, of radioactivity, quanta, relativity, complementarity, uncertainty, the wave function, superposition, and entanglement. The Solvay Conference gave rise to a revolutionary new theory called quantum mechanics. The theory rocked many of the scientific as well as philosophical truths of the 20th century. Not all of the physicists left Solvay in agreement. Einstein and Bohr differed on fundamental principles. They would gather again in Princeton in 1939. But powerful forces were about to be unleashed within the atom as well as within Europe. The physicists produced a letter and an article that would change the course of history. The letter from Albert Einstein and the Hungarian physicist Leo Szilard was sent to Franklin Roosevelt. They warned the president of a new source of incredible energy from the splitting of an atom that could well lead to the construction of extremely powerful new bombs. 1 month later, John Wheeler and the Danish physicist Niels Bohr produced an article on the mechanism of nuclear fission. It was published September 1st, the same day Germany invaded Poland and the beginnings of the Second World War. A political chain reaction followed: the Manhattan Project, Los Alamos, and the dropping of 2 atomic bombs on Japan. 7 years later, after the bomb helped end the Second World War and start a Cold War with the Soviet Union, Einstein voiced his regret for the inability of humankind to manage the powerful technology he and other physicists had brought to life. Quantum mechanics is sparking a new revolution in computing, communication, and artificial intelligence. Instead of a letter or an article, we decided to make a film. The film is about a new power, soon to be unleashed by the quantum revolution, that entails new opportunities, as well as new dangers, that requires new thinking if we are to avoid disasters. When will it happen? What will it mean? Who will benefit?
There were many of the scientists who were involved in the Manhattan Project who had second thoughts, and since almost first thoughts. The first thought Bohr had when he heard about the program was not really how to do it scientifically, it was to think about the political effects as the first reaction.
So as a result of these Bell experiments, we have to accept that nature is not classical. We have to accept that our way of thinking about things is actually to some extent wrong.
People who actually started quantum mechanics also had a hard time understanding it and explaining it, and it is still considered one of the most exotic fields of all of science.
We can actually test it. It's an invitation to take a philosophical question into the lab. And how often do you get to take philosophy into the lab? So that is somehow for me the most captivating thing.
How much do we want to commit to the quantum race as a metaphor and embed a competitive logic into that?
We speak somehow about the quantum revolution as if it has not already started to occur. The fact is, almost everything around us is powered by our mastery of the most basic phenomena in quantum mechanics.
There are still at least 4 strong competing technologies to see which one will be the best technology for quantum computing.
As a scientist, fundamentally, the most rewarding thing is, can you control the quantum world? So it's really understanding nature at its fundamental level.
What I love about building a quantum computer is all these concepts become very natural for you.
Every country that has the resources is probably trying to develop a quantum computer, because it would, if developed, it would actually, in effect, break many of the security protocols that we use on the internet.
If something it's important to you to secret today, and you wish it to remain secret for a year or 2, like a credit card number, there's no consequence. Just continue as you do today. But whenever you're encrypting something for which you wish it to remain secret in 20 years, you're taking big risks.
What I'm taking away from the quantum theme is the kind of end of one overarching way of looking at the world.
If we accept that our current language and way of understanding science and politics is Newtonian and it's classical, and that's the way we think and the way we act, it's also the way we frame our quantum questions.
I think physics is central to quantum answers. I don't think physics is central to quantum questions.
The quantum turn in world politics and economics is extremely important because it reminds us that the world is in fact heteropolar.
I believe this is an important contribution to the way we think about social sciences, because it opens maybe different ways for looking at reality, how we are actors in the world, and how we may make a change in the world.
From quantum, I have learned to think differently about how to think.
Consciousness, and by extension, human subjectivity, is a macroscopic quantum mechanical phenomenon. We're basically walking wave functions.
I believe that life is kind of uniquely poised between the quantum and the classical world.
I think we're all quantum, so in that sense, I would say we could say that we're quantum computers, but I don't mean anything particularly exciting by that. So
instead of kind of conceptualizing development in this area as mirroring the space race or the arms race during the Cold War, but instead take this opportunity to use science and technology as a vehicle, a driver for international cooperation.
This is the ultimate mystery to solve, how the universe works.
A time is coming where we're going to be making use of those distinct and different aspects of the quantum world and using those different aspects for revolutionary, disruptive things.
I think the best possible uses of quantum computing are going to be applications of quantum artificial intelligence.
I'm sure people will find a way to use quantum computers in warfare. There is no doubt about it.
Anything useful is weaponizable.
Will China get there first, and what does that mean for international politics? Obviously, it depends on where there is.
The distance between we and God is a quantum computer.